Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. We're working on our last set of examples for the binomial problems. I'm going back to the same example from last time suppose Spence is late to work 82% of the time. We observe 10 random days and record the number of times late. So n is still 10, p is still 0.82, and we're going to have different problems as far as x. Now the last examples we did were exactly. So we used the Binomcdf, exactly 3 days, exactly 5 days, exactly 8 days. That's all Binomcdf. Now we're going to want to use a different function that's a little faster when we have intervals that we're looking for. So if we look at the first one, it says, what's the probability that Spence is late less than 5 days? Less than 5 days. Well, what does that mean, less than 5? That means the interval from 0 to 4. 0 to 4. Okay, and let me kind of kill that tail there. 0 to 4. That's what less than 5 means. And we want to know the probability of that. Well, we could do the Binomcdf of 0, 1, 2, 3, and 4 and add them all up, but we have a function that's called the Binomcdf that does it for us. So if we enter Binomcdf, which is, you do second vars, and you'll find the CDF right below the PDF. We still enter in 10, and then we put in p, 0.82, and then we put in x as 4. And what this will do, the C stands for cumulative. So the cumulative will add up from 0 to 4, the probability of 0 to 4 outcomes, which is exactly what we want. So if we type in the probability the Binomcdf of 10, 0.82, 4, that will add up from 0 to 4 for us, and we'll get 0.0037. Okay? Next, what about the probability of more than 3 days late? So what is more than 3? Well, more than 3 in this problem means 4 to 10, because we're going up to 10. So this one's a little trickier. We can't just do the CDF of 10. We gotta, because that would give us the probability of 0 to 10. So what we actually have to do for this one, when we have a greater than problem, we have to do this. We have to do actually the CDF. We're going to do the CDF of 3. If we do the CDF of 3, that will give us the outcome from 0 to 3. The 0 to 3 is the complement of 4 to 10. So the way this works is we do 1 minus the binom CDF of 10.82 and then the number 3. And why are we doing the 1 minus again? Because if we do this binom CDF of 10.82 and 3, that's 0 to 3. So if we do 1 minus, then we'll get 4 to 10, which is more than 3 days. So you do that, 1 minus Binomcdf. I'm going to run out of room. I'm not even sure if I'm going to be able to put this up. Binomcdf of 10, 0.82, 3, and we get 0.9996. 0.9996. And I don't have any room to write it. Don't worry about that. I'm just showing you the process. Okay, next. Let's say we want to know the probability of showing up late. At least 7 days. So what does at least 7 days mean? Well, that means 7 to 10. Okay, get ready for at least showing up a lot of times in these probability problems. Okay, so at least 7 means 7 and up, and that's up to 10. So in this case, once again, when we do greater than problems, from like a number up to 10 or a number up, we have to do 1 minus. The CDF, if we do the CDF of 6, that will give us 0 to 6. So we write 1 minus binom CDF of 10.82 and then 6. And that gives us the outcomes from 7 to 10. Because we're getting rid of 0 to 6. When we do 1 minus, we're saying everything but 0 to 6. Okay, the next problem. Let's say we want to do the probability that I'm late at most 6 days, at most. At most means 0 to 6. At most, remember, is a little backwards. At most and at least are kind of reverse of what you initially would think. At most, 6 days means 0 to 6. Well, this is easy. This is exactly what the Binomcdf does. We can just enter in Binomcdf of 10.82 and then 6. And that will give us our answer because that will add up from 0 to 6. So remember, these ones that start with 0, that's exactly what the CDF does. But when we don't have an interval that starts at 0, we have to play some games with this. So let's look at the last one. What's the probability that we show up late between 4 and 8 days? Well, the way this one is going to work is this way. If we start out, so 4 to 8, we just mean we're including from 4 to 8, right? So we got to start first with the Binomcdf. I'm going to abbreviate because I'm going to run out of room. BCDF of 10.82, and then 8. That's our higher number. If we look at that probability, the Binomcdf of 10.828, that will give us the probability from 0 to 8. But we don't want from 0 to 8, we want from 4 to 8. So we're going to have to subtract off from 0 to 3. Well, how do we do that? We pick the Binomcdf of 10.82 and then 3. And that gets rid of 0 to 3. So what we've done is we started with 0 to 8 by doing the Binomcdf of 8, and then we get rid of 0 to 3 by subtracting off the Binomcdf of 3. That gives us 4 to 8, the interval that we want. So make sure that you look at these examples. These are all the kind of questions I like to ask on the test, is certain intervals that you have to first know what they mean, what do the words mean as far as an interval, and then working the CDF so you get the interval. If the interval starts with a 0, like 0 to 4 or 0 to 6, like A and D, it's simple. You do the CDF of the big number, and that adds up from 0 to that number. If you have a different kind of interval that goes up to 10, like 4 to 10 and 7 to 10, you can do 1 minus the CDF of the number to the left of the lower number. Okay, so 4 to 10, we did 1 minus CDF of 3. 7 to 10, we did 1 minus CDF of 6. Lastly, if you have a between problem, you always want to do the CDF of the bigger number minus the CDF of 1 to the left of the smaller number. 4 to 8. So we want 4 to 8, we do the CDF of 8, but we don't subtract the CDF of 4, because if we subtract the CDF of 4, we're going to get 5 to 8. So when we do 4 to 8, you got to remember, you always go 1 to the left of the lower number because you want to get rid of what's below, not of what you want to include. So keep that in mind. Go over these examples again. They'll be on your test, and we'll see you soon. Good luck.